A minus times 3.
All right, everybody.
In one semester, so it's like
Here we go.
3.98. Yeah.
I gave everybody a sheet on this, right? And everybody has the instructions. These are super long problems. All right? These are super long problems. Everybody, here we go. A particle moves, and everybody, you got to think of this particle moving in a line. It's moving left, and then it's moving right. It's moving back and forth. You don't need to have a graph, but a lot of times it helps. And the reason I put up my own problem before we try to tackle 1 and 2 tomorrow is I really like a problem that factors. I really like starting with a problem that factors. In fact, we might do another one that factors tomorrow. Because if I do this, does everybody see it's going to be this graph? I just factored it. And everybody, I can quickly see my 2 zeros, 0 and 6. So from the standpoint of making a graph, 1, 2, 3, 4, 5, 6, I know 2 points immediately on the time. I know I got zeros here. Guys, this is a cubic. Do you guys agree we know it's end behavior? It's going from negative infinity to positive infinity, and it has a multiplicity of 2. I don't know if you remember your pre-calc. So immediately, I know it looks like this. Right? But everybody, let's be clear. I got to erase some stuff because our domain is time. Well, our domain is time. So we know it starts at 0, bounces, and there's what the particle is going to do. Everybody, I don't know this point. I don't know this y value. You guys agree? It's some distance. But fortunately, this is finally where calculus is going to start helping us. Because I could graph this and trace it. You guys agree? But now, we know some really cool stuff about this peak here. All right, we're going to go through this here in a second. All right? This is S equals F of t. Time is in seconds. And this is a good old American problem. They put the distance in feet. All right? So what I have here, guys, is a graph of S of t. I have what's happening to that particle. Where is it at time 0? It's at 0. Guys, where is this particle at time 6? 0. So this is a pretty boring particle. It's definitely moving to the right. So, you know, here is at 0. If we make 0 right here, it goes right, you know, for a couple seconds. Then it just turns around and goes back. And that's really hard to see here. But I see a increasing function and then a decreasing function. Everybody, what's the units of the derivative going to be? Not what it is, what are the units going to be? Feet per second. Everybody, I've only mentioned it once, but anytime we have a position function, the first derivative is the velocity function. Guys, feet per second, right? Just like driving your car to school this morning. So it says find the velocity at time t. Everybody, that is so wickedly simple. I'll change the color. Guys, what's the derivative of f of t? 3t squared minus 24t plus 36. I just found the velocity at time t. Everybody, this is what gets us. We should be able to look here. Do you guys agree at time 0 it's going someplace? If I plug 0 into my velocity function, what do I get? 36. Guys, this particle is moving 36 feet per second at time 0. It is flying off, right? So it says, when is the particle at rest? What is the velocity after 1 second? Sorry, letter B. So, guys, how do I find the velocity at 1 second?
Plug in 1.
Plug in 1. So V of 1 equals 3 times 1 squared. And this is probably more work. So negative 12 plus 3. And this is what's hard. Everybody on the APs, thus in my class, whoops, not meters, sorry. You've got to put the units. And there's nothing on the function to make you remember to do units. You guys agree? You just got to know. Up here it was feet and it was seconds. Velocity's got to be feet per second. All right? So velocity after 1 is feet per second. All right, we got letter A and B. What's next? Letter C. There's A and B. Everybody, when is the particle at rest?
Never.
Okay, what's particle at rest mean, everybody? Not moving. So what's the velocity at that instant? 0. So everybody, for letter C, I want to know when V of t is 0. You guys agree?
It's the peak.
All right, it is going to be the peak. Everybody, I want you to look at the position graph and know that that is velocity 0, that little black X. That is when it was going forward, right, going this way, and all of a sudden at 2 seconds, it starts going the other way. Guys, this is an intermediate value theorem problem. If you're driving your car at 15 miles an hour forward, and you want to go backwards, even if Porter's driving and throws the car in reverse at 3 miles an hour forward, what happens? He has to go through 0 before he starts going backwards. Guys, this is intermediate value. So, we get here, and I know the velocity function was 3t squared minus 24t plus 36. And I want to know when that equals 0. Guys, you look at this. What do you think I want you to do with this problem? If I want to set it equal to 0, what's the next thing we do? Everybody, let's factor. Guys, we always factor if we can. And that's one of the reasons I pulled my own problem to start with. This would be a non-calculator problem on the AP. They would expect you to do this factoring. Everybody, instead of factoring the 3 out, which you could, you guys agree? Since this equation, can I just divide every term by 3? Yeah. All right.
Wait, why can you divide it over not put like the 3 there? Like just divide it.
Because I divided 3, 3, 3. I did both sides every term. What's 0 divided by 3? 0. All right, so now, do we all agree this factors in the t minus 2 times t minus 6 equals 0? What are the 2 times? 2 and 6. All right, so my graph, which I made over here, is kind of crappy. You guys agree?
Yeah.
So this is time, so I suppose I should make it a little better. But everybody, there's my 0, right, at 2. And there's my 0 at 6. I don't know if anybody caught that the velocity is 0 at 6 again.
Wait, wouldn't it be 0?
So it's asking when is the particle at rest? It's at rest at time 2 and time 6. Seconds. Units. Seconds. Nothing in the problem to remind you of it, except you get to the end, you got to say, does this number have units? And the answer is yes. All right? Whew, that's letter C. That's letter C. So I'll make that somewhat small. I might need it, I don't know. Letter D. When is the particle moving in a positive direction? All right, so when is the particle moving in a positive direction?
0, 2.
All right. Try to make the graph a little better. There. And we know now that at 2 and 6, right, the velocity was 0. There, that's a little bit better graph.
0, 2.
All right, everybody, let's start with this. When is the particle, what's it mean that's moving in a positive direction?
It's on the right.
Slope.
It's going to the right. Guys, I want to know when this particle is moving to the right. So that is a velocity. Everybody, I want to know when v of t is greater than 0. I want to know when it is going to the right. Okay? So, I come back. I know v of t is 3t squared, right? Minus 24t plus 36. It comes up over and over and over. There's v of t. How am I going to know when that's greater than 0? Well, this is something, again, coming back from Algebra 2 days now, right? I want to know when this quantity is greater than 0. Now, the nice part is, what did we already find? We already found the zeros, 2 and 6. You guys agree? Up here in this part, we already found the velocity of 0 to 2 and 6. So everybody, again, I can simplify this. I'm not going to spend time with it because we divide by 3 and factor. We did that in the previous problem. There it is. Guys, what intervals do we have? Well, we have 0 to 2, 2 to 6, and 6 to infinity. I'm going to mark this up, make it a little smaller so I can get some room here. Again, anytime we have an inequality with a quadratic, right? We find the zeros, and can you guys picture we have a number line, starts at 0, right? Times 2 and times 6 we know are equal to 0, right? So we have 3 intervals to check. We have 3 intervals to check. Everybody, looking at the graph, what do we know about after 6? Particles run up, and away. You guys agree? So let's put in a big number here. Guys, if I put in 100 for t, that's to the right of 6. You guys agree? T is 100. And you look here, and when I say this, guys, I'm actually doing this math in my head. And I'm asking the question, is that going to be true or false? True, guys. 98 times 94. This is definitely positive, right? Definitely positive. Everybody, I'm going to now do a time between 2 and 6. What's your favorite time between 2 and 6? 3. Awesome. Guys, when you put 3 in, what do you get? You get a negative number. You guys see it?
Yep.
So this is negative. Guys, I'm going to put another number in. I'm going to put in time 1. Negative 1 times negative 5. 2 negatives make a positive. So guys, I now have a graph, right? So now we got to do intervals. So when is the particle moving in a positive direction? Letter D. 0 to 2. And then 6 comma infinity. Because it didn't give a cap, did it? This is like, guys, this is almost real life like physics. If you're into physics, this is like a neutron. Right? When you knock a neutron off an atom, it hangs around for a little while, and then it just disappears into the universe, right? It doesn't hang here. But guys, it's not 0 to 6 seconds for a neutron. It's like 0 to 6 nanoseconds. So if you go up to Madison, they actually do this, right? Yeah, in the plasma physics department. I've seen it. Because my brother does it.
Oh, really?
My brother's a plasma physicist. Guys, this is plasma physics right here. Except the time is too high. All right. If you're in my engineering class, we go. All right? All right. Everybody, this is the hard one. I want you to find the total distance traveled from 0 to 6. All right. Everybody, this is a big problem for us, and this confuses students all the time. Letter E. I want to find the total distance. Let's go through what's happening here on this graph again. You guys, I agree, I start at 0. I go over here to time 2, right? And then I turn around and I go back for 4 seconds back to here. Guys, where did I start? 0. Where did I finish? Is the distance that I traveled 0? No, my position is 0. Guys, I traveled to the right for 2 seconds. I got over here. I traveled some distance. Then I turned around and what did I do? Traveled back.
Same distance.
Same distance. Guys, I got to know that distance. If I'm going to find the total distance traveled, I have to understand that that's what's happening. And this is hard because you have to look at the function now. You know the derivative. So guys, you can't do this without finding the velocity function. You can't really do this without finding the velocity function so you know where this point is. So guys, I'm really interested. You guys agree that not V, well, you can write that. You guys all agree V of 2 is 0? I know that. So I'm really interested. Where did I start? What is S of 0? So I go back to my original function. We know it starts at the origin. Guys, I really want to know where I'm at S of 2. Because that's going to tell me where the particle travels. So I got to put 2 into this equation. All right, so I'm not going to do the math longhand. 2 cubed is 8. 2 squared is 4. That's 48. 8 minus 48 is negative 40. 72, right? Negative 4. How about 32? Guys, 32 what? Feet. Now, everybody, what is S of 6? 0. 0 feet. All right, the answer's not 32. The answer's not 32. The answer's not 34. The answer is 64. Can you guys picture it now? So again, everybody, we can go through the math all we want, but you traveled 32 feet to the right in 2 seconds, and you traveled 32 feet to the left. Guys, this is absolute value time. It's positive 32 and negative 32, but if you drive your car in reverse, the odometer still puts miles on. Otherwise, I'd be driving backwards home, so my car would never, ever put mileage on the odometer. Guys, the total distance traveled here is 64 feet. All right? We are not going to draw a diagram today. We're already running against time. All right? We are going to get to the next thing. All right? We're not going to draw a diagram today. All right. Everybody, letter G. Find the acceleration at time t after 1 second. Second derivative. So guys, I want d squared f dt squared. Or I want to write that as f of prime prime t. Or I want to write that as v of prime t, right? Because the derivative of f was v. This is getting confusing. Do you guys agree? But it's hard to follow, but we got to write these out so we start seeing them. Guys, I really want to know the acceleration at time t.
Why is it d squared f over dt squared though? Like, what does that mean?
That means that I am taking the rate of change of f over the rate of change of time 2 times.
Well, like, how do you figure that out though? Like,
Okay, so let's figure it out. We already did this, guys. Do we all agree that we had f prime of t was 3t squared minus 24t plus 36? Guys, what's the next derivative of f? Guys, it's 6t minus 24. You guys agree? Derivative of the velocity function, 3t squared minus 24t plus is 6t minus 24, right? So everybody, the velocity function is 6t minus 24. Guys, the derivative of position is velocity. Derivative of velocity is acceleration. If you're going to engineering, derivative of acceleration is jerk. Remember? And that's how your head snaps as you go down the roller coaster. All right?
Who came up with the d squared of f over dt squared equals just the double, like how?
Why is it that way?
Yeah.
All right.
Why is it?
All right. Let's say, hang on. I can go through this. This is worth knowing. Oh, the 2's here. So guys, I want to be clear. Do you guys understand this means take the derivative?
Yeah.
All right, and I want to take the derivative of f of t. Okay, that's the first derivative. Then I want to take the derivative of the derivative.
Yeah.
What's d times d?
D squared.
What's dt times dt?
dt squared.
Look at our notation. D squared f dt squared. That's where it comes from. All right? Everybody, we have to recognize these all as equivalent derivatives.
So shouldn't it be d squared t squared or no?
D squared dt squared. dt dt.
Why is there not like a parenthesis around the dt?
Because we don't want that amount of writing.
Oh.
And this is just shortcut notation for what this means.
Okay.
All right? So you're looking for reason. I appreciate you looking for reason, but guys, this is just notation.
Okay.
And remember I said there are like 7 or 8 different ways to do the same damn thing? right? That's what's happening to us right now. All right, we still haven't answered the question, everybody. That's what kills you here, right? We've done all this work. We haven't answered the question in G. It said find the acceleration at t, done, and after 1 second. Guys, what's the acceleration got to be after 1 second?
6.
You put in 1, right? 6 minus 24. All right, and you've only gotten half the credit on the AP.
You have to put the units.
Units, which is feet per second squared. And there's little letter G. All right. Woo!
This is a whole question on
Well, this would be, actually, guys, you would pray for one this easy on the AP.
what?
All right. No, typically, guys, they would not lead you through the process. Guys, on the AP, they're just going to ask you for E. They're going to start right off and say, find the total distance of the particle travel.
But that's going to be like.
But you have to find then velocity. You have to do these steps.
Oh, yeah.
But you're not ready for that yet. But guys, often the AP just starts with letter E. Right? It says find the total distance because you have to do everything else. Right? You have to find when the velocity is 0. So you know how far the distance traveled, right? All right? All right, everybody. It says graph the position, velocity, and acceleration function from 0 to 6. Everybody, you can do this in your calculator now. You agree? If you need to graph these, or on Desmos, we now have 3 functions. We have the position function, we have the velocity function, and we have the acceleration function. All right? Everybody, here's the cool part. We knew that the position function was cubic. What is the velocity function? It's a parabola, right? It's quadratic. What's the acceleration function? It's linear. Guys, it's just the progression of these things. I'm looking at the clock, and we're not going to have time to do this. I can put them up, but I am going to skip this. We'll put this on Desmos in a second. I'll do it from my computer, but I'm going to jump to I first. Let's do the last bit of math. When is the particle speeding up? When is the particle slowing down? Now, this is really rough. Everybody, I am going 55 miles an hour coming into school every day. You guys agree? Because I don't speed. And I'm coming down to the 4-way stop, right down here. I'm passing these houses on Old 92 because I come from Broadhead, right? And I'm coming up to the 4-way stop. And I'm going 55 as I fly around the corner there. Tires screeching. But I got that straight section, right? Guys, I'm driving 55. I hold my foot on the pedal. I pull my foot off.
Yeah. You started slowing down.
I start slowing down. Guys, is my velocity positive when I pull my foot off the pedal?
No.
Yes.
Yes.
Wait. Oh no, your acceleration.
All right.
is negative.
My acceleration's negative. So you got to be really careful here. So when is it slowing down? Right?
Oh.
Is when I have a negative.
Velocity.
No.
No.
Acceleration.
Negative acceleration. When the particle is speeding up.
Mixing up in my head.
All right, I have a positive acceleration, but that's only if I'm going forward. All right, because
What if you're going backwards?
what if I'm going backwards?
Oh boy.
All right, so guys, if I'm in reverse
What in reverse, there?
and I'm going backwards at 10 miles an hour and I slam on the pedal and I'm watching over my shoulder
Oh, there goes Billy. He's dead.
and my acceleration is more negative. Am I speeding up or slowing down? I am speeding up because speed is. So this is really a tough problem
Yes.
because guys, you got to use acceleration, but you have to understand: is my velocity positive or is my velocity
Negative.
negative?
Oh my gosh.
Because speed, guys, listen, guys, if I'm in reverse and I'm going 5 miles an hour and I slam on the accelerator, and then I'm going 15 miles an hour, and then I see Thomas and I slam on it harder to go 20 miles an hour, guys, my speed is increasing. My distance to Thomas until he flies up over the back of my van is decreasing. All right? Everybody, this is a wickedly hard problem.
So there's
All right.
2 accelerations.
I have my dreams, right, guys? All right, so probably gonna put this on YouTube and lose my job. All right, so everybody, there's a huge problem here. Before you can start doing this, you got to define where is the velocity positive and where is the velocity negative. And we've done that way back here, right, on letter D. Guys, we agreed the velocity was positive from 0 to 2, and we agreed the velocity was positive from 6 to infinity. So for v of t greater than 0, we had velocities. We had these two intervals. You guys agree? Does everybody agree with that? That was there. Obviously, if that's the positive sections, the negative section is between 2 and 6. All right. My acceleration now from the previous part is 6 minus 24. All right. So, guys, if I have acceleration equals 6t minus 24, in the first interval, if I plug in 0 to 2, any value here,
1.
if I plug in 1, what's my acceleration going to be, positive or negative?
Negative.
All right, so, do you guys agree A is going to be less than 0 in this interval? So guys, my velocity is this way, my acceleration is this way. Am I speeding up or slowing down? I'm slowing down. I'm slowing down, so this is a slow. All right. Let's go in order. Let's go over here to 2 to 6. Again, A of t is equal to 6t minus 24. Uh-oh. Uh-oh. I can see a problem right now because I plug in 2 and I get a negative number, and I plug in 6 and I get a...
That means you're accelerating.
Oh, wait a minute. I got to break this interval into 2 more parts. Oh, because I have an acceleration that's going to be positive, and I'm going to have an acceleration that's going to be negative. Everybody feeling the pain? Everyone, these are huge problems. These are huge problems. I just like to introduce them on this. Everyone, I love this problem. I picked this one for a reason. Guys, when is the acceleration 0 for 6t minus 24? What time?
4.
4. You guys agree?
Yes.
So,
4 to
I'm
6.
going to break this into 2 comma 4,
4,6.
4 comma 6. Acceleration is negative here. Acceleration is positive here. But guys, what do we know about the velocity in the whole way? It was always negative. Negative velocity, negative acceleration means you are speeding up. Negative velocity, positive acceleration means you are slowing down. All right, I'm about there, Last one, between 6 and infinity. Everybody, what's the acceleration going to be here? It's definitely got to be positive, right? Because it's like 10. So now, guys, velocity is positive, acceleration is positive. Both going the same way. You are speeding up. So this is speed up. This is, I said down, or this is slow down. Woo! And I bet you it's a 15-minute video, which breaks my rule of going 10. But these are very difficult problems. Here's what I want you to get out of this. Everybody kind of get a rough feel for total distance, the idea of it, and the idea of speeding up and slowing down has nothing to do with, you have to have 2 signs, right? You have to compare the velocity and the acceleration. Because if you're running in reverse and you want to run somebody down, you are speeding up.
Wow.
Guys, that's it for today. All right, I'll have it graded. Bye, YouTube. Hi, Scott.